Hey everyone, and welcome. So today, we're going to climb what's called the Ladder of Abstraction. It's a journey that's going to take us from the actual physical computer sitting on your desk all the way up to that invisible cloud that pretty much powers our entire digital world. And it's a journey that's going to help us finally answer one of the most annoying questions in all of tech. Let's get right into it. You know the one I'm talking about, right? You've definitely said it before, or heard it. Well, it works on my machine. Why does an app run perfectly fine on one computer, but then you try to run it on another and it just completely falls apart? It's a super frustrating problem. And honestly, it's the driving force behind this whole evolution we're about to unpack. Okay, so to figure this out, we've got to pop the hood. You see, a computer isn't just one thing. It's actually a stack of layers, kind of like a cake, where each layer is built right on top of the one before it. And understanding this stack is the very first step up our ladder. And that gets us to this really core idea called abstraction. You know, it's kind of like driving a car. You don't need to be a mechanical engineer and understand the engine's combustion cycle just to press the gas pedal. The pedal is a super simple interface that hides an enormous amount of complexity underneath. Well, computers are built on that exact same principle, using layers of these simple interfaces to manage all the complex stuff happening behind the scenes. All right, so way down at the very bottom of the stack, we've got the ISA, or the Instruction Set Architecture. You can think of this as the hardware's mother tongue. It's the absolute basic set of commands that the processor actually understands. It's really the fundamental bridge between the physical circuits and all the software. Now, take one step up from that and you'll find the API, or Application Program Interface. This is our gas pedal. When a developer types a simple command like print this file, the API is what translates that simple request into all the complicated operations the system needs to make it happen. It's basically the simplified menu for a super complicated kitchen. And the glue that holds all this together? That's the ABI, or the Application Binary Interface. Think of it like a universal travel adapter. It's the critical translator that makes sure the language the application is speaking matches the language the operating system is speaking, so that everything just plugs together and works. Now here's the kicker. These layers make everything possible, but they're also the source of all our compatibility problems. So how did we even begin to solve this mess? Well, the first big idea, the first major step up our ladder, was something called virtualization, and it was a really clever way to deal with all those hardware differences. And honestly, the idea was pretty brilliant. What if we could just create a complete, self-contained software version of a computer with its own virtual hardware, its own virtual operating system that could run on top of our real computer? And that's a virtual machine, or a VM. So suddenly you could run a full-blown Windows computer inside a window on your Mac. How cool is that? So what's the magic trick here? It's a piece of software called a hypervisor, and there are two main flavors. Think of a Type 1 hypervisor like running barefoot. It sits right on the hardware, so it's super fast and super efficient. A Type 2 is more like wearing shoes. It runs on top of your regular OS, which makes it way easier to get started with. Think of something like VirtualBox. But, and there's always a but, right? VMs had a huge downside. They were massive and slow. If you wanted to move an application, you had to move its entire virtual computer. You literally had to boot up an entire second computer with its own operating system, wait for all the services to load, all just to run one little app. It was powerful, for sure, but man, was it inefficient. So that inefficiency, that heaviness, it just begged for a better solution. And that brings us to the next massive leap up the ladder, a new approach that really changed the game: containers. See, containers flipped the script entirely. Instead of virtualizing the hardware, they asked a way smarter question. What if we just virtualized the operating system? What if we could package just our app and only the specific things it needs, and then just let it share the main OS with a bunch of other packaged apps? The best way to think about a container is like a perfectly packed lunchbox. It has the application, all its libraries, all its dependencies. Everything it needs to run is neatly bundled together. And you can give that lunchbox to anyone, and it doesn't matter what their kitchen looks like at home, it's going to work exactly the same. And when you put them side by side, the difference is just staggering. I mean, we're talking gigabytes for a VM versus megabytes for a container. Boot times of minutes versus literally seconds. It's a whole different ballgame. They are incredibly lightweight, super fast, and unbelievably portable. And this is what finally solves our original problem. With containers, that dependency hell just vanishes. That lunchbox contains everything it needs. So that dreaded phrase, well, it works on my machine,
It finally becomes it works everywhere. Because you're not just sending the code anymore, you're sending the entire perfectly set up environment along with it.
But here's the thing, the wild efficiency of containers didn't just fix an old problem, it completely unlocked a new way to build software, especially for the cloud.
So instead of building a giant online store as one big, clunky program, imagine building it out of Legos. You have a little Lego brick for the shopping cart, another for payments, another for the user login. Each one of these little services runs in its own container, which makes them super easy to update or scale or even replace without touching anything else.
Okay, so that's awesome, but it creates a whole new problem, right? How in the world do you manage hundreds, maybe even thousands of these little Lego bricks or lunchboxes? Well, that's where something called an orchestrator comes into play. And the big one you've probably heard of is Kubernetes. It's like the conductor for a massive container orchestra. Okay, let's take a breath. We've climbed pretty high. We've gotten rid of the hardware with VMs, and we've gotten rid of the OS with containers. What could possibly be left? What's the very top of the ladder? Well, the final jump, the highest level of abstraction, is to get rid of the server itself. This is the big idea behind serverless computing. I mean, what if you, as a developer, didn't have to think about servers at all, or containers, or any of it? What if you could just write the code? The perfect way to think about this is like an old-school internet cafe. With serverless, you don't own the computer. You just walk into the cafe, use a machine for the 10 minutes you need it, pay for exactly those 10 minutes, and you walk away. The cafe owner, the cloud provider, handles the computers, the internet, the power, all of it. You just show up, do your thing, and leave. Okay, so to be clear, serverless doesn't just replace containers. They're different tools for different jobs. You want containers when you need total control over the environment, for those big, complex applications. But for quick, simple jobs, like, say, resizing an image every time someone uploads one, serverless is perfect. Zero management, pure function. So let's just quickly run back down the ladder we just climbed. We started with the complex, physical hardware. Then virtual machines came along and abstracted away the hardware. After that, containers abstracted away the operating system. And finally, serverless abstracted away the server itself, letting developers focus only on their code. You see, every single step we took up this ladder was about one thing: hiding complexity. It was about letting developers stop worrying about the plumbing and start building amazing things. And that just leaves us with this one kind of mind-blowing question. We've made the hardware, the OS, and now this server effectively invisible. So what's next? What's the next thing we're going to make disappear?